Hello everyone, in this video I want to demonstrate how can you use functional form template to help you to work on any data project that need to figure out what is the best functional forms. Okay, so in this video, for this file, before you watch this video, you should already watch the other one in terms of how to upload the Jupyter Notebook functional form template to your Jupyter Studio, and also a data file called Tractor 7. So make sure you have this file and the functional form template file is upload to your environment. If you do not know how to do that, please watch the other video. Okay, so since I understand most of my students never took any coding classes, so the goal for using the Python in this class is just try to help students get used to the coding, and then I try to introduce as minimum coding requirement as possible. So therefore, all the template I create to you is very user friendly. And in this video, I want to talking about after you download this file and upload to your Jupyter Studio, and then where you can change to fit in your data set. Okay, so first of all, after you upload your Jupyter Note file, double click the file so you will be able to see what I'm showing you on the screen. Like I said, the purpose of this notebook is to illustrate how to run regression with the different functional forms. And in the class lecture, we're talking about different functional forms, linear, double log, semilog 1, semilog 2. The difference between semilog 1 and semilog 2 are semilog 1, we take a natural log on your dependent variable, and the semilog 2 is we take a natural log on your independent variables. And also we have the polynomial model. We're talking about the second order, third order, and the fourth order. So we can make those are considered polynomial model. And also we talk about reciprocal regression model where we find the inverse of x as my independent variables. Okay. Before I start, I also want to call out for our double log and for our semi-log 2 and also our reciprocal models. It is very and also the polynomial model. So basically, when we're changing the functional form, especially when we are trying to adjust in the form of x variables, we are not doing any changes if x variable is a dummy variable, okay? Because the dummy variable can only take 0 and 1 values. So therefore, when we go through our Python code, you will notice that I specifically ask you to call out what is which are your dummy variables, which are not your dummy variables. Okay, so first of all, for the Jupyter Notebook, the code has to be run section, or we call the cell. Okay, so as you see, the first 5 lines of the code, they are in one cell. So when you click this cell, you can see there is a box highlighted. So everything in this code I consider as in one cell. And I click here, the second box here, so that's the second cell. So in order to run this notebook correctly, you have to make sure run cell by cell by cell. Okay, so every cell has to be run. So first of all, for the first cell here, I'm just introducing the packages I needed for this Jupyter notebook. So if you want to learn more detail about what are those packages, first of all, I add a comment. Okay, I add a comment. So everything, so the pound sign after the pound sign, so they are just like a comment. Usually, being a good coder, you want to add as many comments as you want so that people, when they're reading your code, understand what you're doing and what is the intent. Like I said, our focus in this class is not, okay, teach you all about Pythons. We just want to get you familiar with the Pythons and you understand how to use the template I give you to make a certain adjustment to getting the regression output you are looking for. Okay, so like I said, reading the comment if you want to know what are those packages means. But here I want to show you how you are able to leveraging this template to run the data set you have, and especially the data set you have for the lab, and then to finish your homework assignment. Okay, so first of all, how you run the cells. So first, you click after you click the first cells, as you notice that this box become the blue, right? And I go on the top here called the run. And then we will use the first one called the run selected cells. So we only like I said, we do cell by cell because I want to tell you guys what they mean. So we are using run select the cell. Also on the right hand side, you can see it's called a shift plus enter. So basically these are the keyboard shortcut. So instead of always coming here, click run select cell, always click this one. What you can do is find on your keyboard, if you're using Windows computer, you just need to click shift and enter at the same time. So usually you can click the shift and hold it and then push enter. Okay, so I will show you both ways, but if you're using the Mac, I believe the shortcut here will be a little different because you guys have a command key. So whatever, when you click the run on the right hand side here, this is the keyboard shortcut. So if you feel uncomfortable use the keyboard shortcut, you can always come here, click run select the cell. Okay, so let's click run select cells. So as you noticed before, this box was blank, right? Like the box below. That means we haven't run that cell yet. So once you run the cell, it will automatically came a number. So the number, the larger the number means the recent step you did it. Okay, so after I run this cell, I got 4 because maybe I already run something else. That's why it's 4. Oh no, you know what? Because I have 4 lines, 3 lines here, so therefore it start at 4. And now, after I successfully finishing running this line, I got 4. That means I finished running it, and I can go into the next cell. I click this cell, and then this time I'm going to use the shortcut on my keyboard. Okay, I push shift, and then I hold it, and then I push enter. Okay, so as you see that, the second cell also run it. So now it's a 6. So 4 and a 6. So 6 is larger than 4 because the cell 6 is the one I ran after I ran cell 4. The cell indicating is 4. Okay, so some student can ask, okay, what this 6, this cell were doing? Again, when you run in your site, maybe this is 1 and a 2. So it doesn't matter it's 1, 2, or 4 and a 6. It just make sure the first cell run first, and then you go into the next cell. Again, so in this second cell here, you do not need to change anything. And also, please do not change anything because in this section, what happened is we are having, I'm lay out all the function you can use to run different kind of functional form. As you notice here, called a DEF, that means I'm define a function. Like I said, we don't want to go in too deep, in depth on coding because ideally, in order for you to understand what I'm coding here, you actually need to take a Python class. But I want to just explaining what this section doing. So the second section is try to creating different kind of functions, and the function itself will require you to give input. Okay, so we don't need to do any input yet because we later we're going to using those functions. So remember in our regression model, we had one called a linear regression. So basically, first function I creating here is allow you to analyzing the linear regression model. Okay, so for this function, it's required 3 variables entries. df is the data set, your y variable, your continual variable, and then your dummy variables. Okay. Similarly, the second function I'm creating here is called a double log regression. Your data set, your y variable, your continual variable, and your dummy variable. Okay, so I had a semi-log 1, semi-log 2, polynomial regression, and reciprocal regression. Again, for this section, please do not change any code. So please do not change any code. And then, like I said, after you run this cell, make sure you run this cell so that the computer will remember those functional form. Okay, now let's move on to here. So starting from this section, I'm able to tell the computer where is my data set and then what kind of regression model I'm going to run. Okay, so the data set we are using is called attractor 7.xlsx. So if you look at on the bottom here, this is my data file. So that's what I will put in here. So basically, if you're using this code to analyzing other data set, you just need to make sure changing the file here name to match the file you uploaded here. Okay, and also please do not forget to put your file types. Okay, in this document, all our Excel file is ending with .xlsx. So make sure you keep this functional file name, the file name of your Excel files. Okay, so now let's run this cell so that the computer will read this file. So push Shift on your keyboard at the same time, and then hold it and push Enter. Okay, as you see that it allows us to view certain row from my data set. So if I pull this data set out from my files, okay, so this is my tractor files. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 columns. So basically, we try to predict the sale price of tractors. And so this is my Y variable called the sale price. And for my X variables, I have many, right? I have horsepower, age, engines, hours, diesels, forward, manual, John Deere or not John Deere, and the cab, and then also the 4 seasons, right? So the problem here is that the fact is that age, engine hour, and the horsepower, so they are all my continual variables. And then diesel and the rest of the column, they are all my dummy variables. So therefore, they are all 1 and zeros. So this is a very good data set because it allows you to see how you can introduce in different variables to your model. Okay, so now if you compare this with your Jupyter notebook output here, so basically you see this data file currently is stored in my, is being read by my functional form Jupyter notebook. That's great. Again, so this is one place you need to change the tractor. So make sure you matching your data files name. Okay, after you do that, now we can start to run the regression. So like I said, here I have several different models: linear regression model, double log, semi-log 1, semi-log 2, and a polynomial with a 2 degree or with a 3 degree. You can change it, and also reciprocal. So we will go through them one by one. Okay, so first, for the linear regression model, first of all, we need to tell the computer what is my Y variables by call out the column names. So for Y variable, as I just mentioned, it is called a sales price, right? So I will copy this name to make sure I don't have any typos. So keep in mind, and I will paste here, and make sure you are keep the quotation mark. It is very important for the Python. If you don't put a quotation mark, they were thinking that's a variable, but since we are call out the actual names, so make sure you keep your parentheses here, okay? And next is our continual variable. So let's see, we want to build a regression model that have all of the variables included. The horsepower, age, engine hours, and then the rest of them are dummy variables. So therefore, I will copy all of my variables and including that horsepower. Okay, and then after you are including the horsepower, and then after this, comma, and then you make sure you had the quotation mark, and then you go into the second variable, that is age, and then after that, after that, age. Okay, I will stop at here because the other variables are my dummy variables. So therefore, for other variables, and I will put down here the dummy variables. Okay, my first dummy variable is diesel. And then my second dummy variable is forward, right? The third dummy variable, let me go back to my manual. And then the fourth variable is John Deere, whether it is a John Deere or not. And then the next one is cap. And then the next one, is a spring, summer, and a winter. Okay, spring, summer, winter. Okay, so let me double check, make sure everything's right. Okay, good. So after I tell the computer what is the y variable, my dependent variable, my continual variable, my dummy variable, now I can run this cell now. So this is second place you need to change when you're using this template. So the first is the data file, and then the second is your variables. And then you can hold the shift and push enter, and you run it. Okay, run this cell. As you see, it's 10 now. Now I can run the linear regression output and then push enter. Okay, so this is my simple linear regression multiple linear regression output. Feel free to use Excel to generate results, see if you can match. So as you notice that the output are very similar to your linear regression, the Excel output. So we have this column, this is my coefficient, and now I have my p-value and have my t-statistic. So where's r-square? So on the top here. Okay, so 62.9%. And for the just r-square is 61.5%. And then it gives us a lot of information we can find from Excel if you use Excel. So basically, try to learn how to use my code to develop a regression output, and you can compare this with the Excel. Okay, now we move on to the double log. So let's see for the double log. I just want to make so the y variable are still the same. So I will copy the y variable. Okay, and then for my x variables, I still use the same x variable. So I copy all of my continual variables. And then for the dummy variable, I will copy all of them as well. Okay, so now I will run this cell. Don't forget about run after you changing the code. Shift, enter, and then we run the next one. Shift, enter. So now we have the double log regression model output. So everything you see here changed because they are double log. So first of all, the y variable has taken the natural log, and then for all my x variable also take a natural log. So this is the result. Okay, this is the result. And then the next one is the semi-log. So for the semi-log, as we're talking about, semi-log 1 is the one, if I go back to my functional form. Okay, semi-log 1 is when we only taking the log on my natural log on the y variables. So let's see. I'm still using the same output here. So the y variable is still the same. And then my x variable is the same. And then don't forget your dummy variables. Okay, and now I push enter and push shift enter. Now this is the output for the semi-log 1. And so like I said, the results are different. Compare this one with the previous one because at this time the y variable has taken a natural log. So that's how this, but for our x variables, it doesn't take natural log. So the next one is the semi-log 2, where we take natural log on our non-dummy variables. Okay. So first of all, for this one, I also call out a new column is that maybe you don't want to take a natural log for all your continuous variables. You only need a natural log for certain x variable you want to take natural log. Therefore, I had the one requirement ask you to tell me which x variable you want to take natural log. Okay, which x variable you want to take natural log. So first, the y variable doesn't change. And then the x variable also does not change. And then the dummy variable are still the same. I'm just copying and paste here. However, for the log transform variables, so for the continual variable we have here, so maybe we want one of them or two age. So I have 2h, so somehow I had the typo. Okay, so that should be the engine hour. Somehow I have the two, so let me rerun them a little bit because I had the typo here. Okay, engine hour. So for the linear regression, I'm rerun it. And the same for the double log, and then also for the semi-log 1, and then for the semi-log 2. Okay, so here I want to only transform age. So if that's the one x variable I want to transform, and I'm coming here, put age in it. So if you look at here, horsepower for age, instead of age here become log age, right? So because that's the only variable I want to transform to log. So one thing I want to call out is that if your continual variable is not included here, as your continual variable is not included here, you cannot do the transform log for that variable. So whatever transform log variable you want to transform here, you need to make sure they also exist in your continual variable. Okay, so now the next one is polynomial model with a degree 2. So basically the model itself will look like let's see, this one. So the a here would be 2. Okay, so that is the polynomial, second order polynomial 2 with degree 2. So first of all, for y variable, continual variable, and the dummy variable, so the way we set up are still the same. And then the continual variable are still the same. And similarly for the dummy variable. Okay, so once you set it up, and then you will run this cell. Like I said, you can come here to push run and run the cell. Okay, so or now we finished running this one. Now move on to the next one. Shift Enter. Okay, now I'm getting my polynomial regression model. As you notice that instead of calling the original name like horsepower log age, so all the names are changed to x1, x2 because the second order polynomial model here will basically including the square term for every one of my variables, and then the square term for all of the variables. If you look at here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? And once we get in here, all my non-dummy variable are squared. So basically, we will have 1, 2, 3. These 3 variable will have a square term. So that's why we end up totally 14 variables here. Okay, so that is the second order polynomial model. And some students are going to ask, oh, how about third order polynomial model? So you only need to come here, changing the polynomial degree here to 3, and then push enter. So now you are able to receive this model. It's called a polynomial regression model, third order polynomial regression model. Okay, let me change it back to 2. Okay, so the last one is called a reciprocal regression model. And then similarly, what will happen is we are taking all my continual variable and finding the inverse x values. So therefore, we come in here. The way we set up those variables are still the same. So the first is my x variable, so it's a sale price. And then the next is horse hour and age. And then the last one, the dummy variable are still the same. Okay, so now we need to run the variable and then run this last code. So now we are able to receive this model. It's called a reciprocal regression model. So all the number here change because the horsepower age we seen here when we put in the model go through this function, they taking the inverse of every variable. So therefore corresponding to inverse variables value, so this is its coefficient. Okay, so hopefully this video is helpful in terms of how you can using this Jupyter notebook I developed to help you to work on the lab assignment. And also you should also able to leveraging this document to work on your class project, right? Because in your class project, you only need to make sure you have your data file, and in your data file, make sure you have both continuous variable and a dummy variable. And then after that, you just need to make sure you're selecting the right y variable and identify your x variables, and also identify all your dummy variable that already coded by 0 and 1. And then you can use any one of the model to get in the model you are looking for. Again, always keep in mind what determines the functional form. It is the scatter plot. Okay, so when you're developing the scatter plot, that will allow you to identify which functional form you want to adopt. So please do not forget about the lecture. We're talking about the relationship between the curve, which is your scatter plot, going to show you some kind of curvature or something to determine what kind of functional form you want to use. For this video, just want to demonstrating how you can use the functional form template to help you to estimating different kind of model shapes. So feel free to reach out to me if you have any questions. Bye.